Okay, so hello everyone. Welcome to my session about container orchestration for Oracle DBAs. So I've been sitting in a couple of presentations just now. Can I ask who of you has been sitting in either one of the Istio and the Service Mesh presentations beforehand? A few hands. Okay. Can I also ask who of you is using Kubernetes at the moment in some form or capacity? Very few hands. Maybe more about the top, but I can't really see you guys due to the lights. Okay, well, I have been I've become very interested in Kubernetes sort of second half last year. It's an interesting technology that I think we as Oracle DBAs need to be aware of, even though strictly speaking, it's not necessarily something that touches the way we work with a database, but it's definitely something you cannot ignore, in my opinion. Moving forwards, because the backend will be exposed in a way that makes it Kubernetes compatible. I'm pretty sure about that. There are lots of developers out there, and if you read the Java magazines and the general IT magazines about JavaScript development, Python, and so on, you will definitely find lots and lots and lots of articles by people quite knowledgeable about that topic, where some sort of container orchestration is being used, or at least, definitely being used to talk to an Oracle database backend. So before I'm going to start, I'm very briefly covering who I am. My name is Martin. I work for Accenture Enkituk Group, and what I'm saying here is strictly my own opinion. I have contributed to DID tree literature, the Oracle database mainly, and I like blogging under this URL. And if you have any questions, feedback, or whatsoever, you can use my Twitter handle, which I've got there as well. Okay, and having said that, let's move right into the contents, because I think, as always, I have a few slides too many, so I'll keep that, I'll try to keep that condensed as much as possible. So what you are going to hear from me today is an introduction about microservices, containers, and Kubernetes, then some container essentials before I'm talking about container orchestration. And it appears as if my live demo was working. Let's have a quick look at it and see if it didn't get stage fright. No, the mouse is still moving. Okay. Right. So the worst thing that can happen is now my internet connection dropping, but I don't think that'll happen. I'm confident all the demo gods will be with me today. Okay, so the introduction to the topic is all about distributed applications and microservices. And as I have said before, when you look at how people develop applications nowadays, it seems that some sort of microservice component always has to be part of it. Otherwise, the application wouldn't be modern and cool, and people don't like to write these things for new developments. And I have always wondered how that affects us as Oracle DBAs, and how that actually looks like end to end. There are lots of blog entries you can find. There are official white papers on how you could develop these things. But what I was missing really is from a front end connecting to a back end service, pulling data from a database and displaying it. How does it really look like if you deploy the front end and the potentially also the REST API into Kubernetes? I have seen lots and lots of opinions about stateful applications. I'm going to talk about those in a bit, but it appears that the general consensus at this point in time is that you keep the database out of Kubernetes. So I was proposing something like that I wanted to develop something like it to a good friend, and he said, but I hope you keep the database out of Kubernetes, and that's what I stuck to. So you will see that later when I'm going to talk about the front end. So the front end is something I haven't really used previously. The demo application is based on JavaScript, and it calls a REST API, which connects to an Oracle XE database, which I'll show you later. Okay, so having talked about that, what the literal hell are microservices? They're really the most important part of this whole presentation. So as always, if I don't really know what something is, a good starting point is Wikipedia, because if you start there and take what you find on Wikipedia and validate it with other sources, you might actually end up with something that's halfway correct. So what's a microservice then according to Wikipedia? Well, it's a microservice is small, it's messaging enabled, it's autonomously autonomously developed, independently deployable, decentralized, and built and released with automated processes. That sounds like software developers' heaven to me. I really like that definition. And it's actually down there if you want to look it up yourself. So what does that really mean? So those of you who've been sitting in the other Istio presentations beforehand, apologies. I've got to go over those in real quick. So it means small. Small there isn't really consensus about what small is. I suppose it's something that a team can develop. There are definitions out there where you say, the team shouldn't be bigger than what 2 pizzas can feed. But I guess that depends on how hungry people are and how big the pizzas are. Messaging enabled. That sounds vaguely familiar. We've been doing messaging stuff. Anyone remember Corba? Why do you remember that? I mean, that must have been... that is the nightmares. You want to keep those in one corner of your brain and don't really think about those too much. But this is kind of... something that's been in the software industry for a long, long time. And actually, I'm thankfully, I'm too young for Corba. I saw that, and that existed, and you would need pre-compilers, and it was all terrible. But then, we had things like BPEL and SOA and so on. So messaging enabled makes sense. Autonomously developed. So that's something I'm going to talk about later, so I'm not going to discuss it in much more detail at this point. Independently deployable is also very important when it comes to deploying of the software. Decentralized means it's kind of a mesh of various services that interact at some stage, and you build and release these automatically. So that would be the end game where you have a code repository, you've got a team of developers, they all check their code in, and at one point you then say, okay, that's good, let's push it out to production. You commit, it commits against your version control system. The version control system then runs a few hooks, such as unit testing, maybe linting, maybe some other things, whatever your compliance regulations require. It goes through an automated process. Passing this, it will be packaged into a format that is mostly Docker these days. And from there on, you could even go so far as to push it out to a test development cluster, from where on the developer then gets a URL. This is where your code has now been deployed. Go test it. They can test it, and once that works, you can push into production, and that's the ideal. So why did the industry get there? So first of all, the whole microservices thing I found applies to some projects, but it certainly doesn't apply to all of them. So just because this is the industry's hype at the moment doesn't mean that it is your hype necessarily, because sometimes these things just don't work in your organization. But the story always goes like this. So there is a lot of pressure to innovate, and what that means is you need to ship your code, and because you want to be quicker than the competition, you need to ship it often. But some of the applications, also some of the stuff I've been working on, has become really hard to maintain. So, for instance, you take an application where multiple applications are actually consolidated into one deployable unit of whatever form it is, maybe a tarball, maybe a zip compressed file that you then ship to your ops person and say with a README, deploy this here, unzip, stop that, start this, so the new code is deployed, and there you go. But it is really hard to maintain these things. The more you consolidate, the harder it gets, because you now have, instead of one team, you've got to ask 2 or 10 or 42 teams, can we do this? So that contradicts the need to deploy fast and often, and it's mainly down to finding a change window, really. Anyone who's worked in financial services will know that finding change windows in some places is really hard, but that's a different story. So how can you overcome these limits of what's always referred to as monolithic software development? So the idea is, just go and break it down into components. If it was a large kind of Lego piece, and you just peel the various ones off, and there you go. That's not a thing that you do in 5 minutes. I have seen tutorials on how you can decompose a monolithic application, and I thought, it's probably the right approach, but it's not something you do in an afternoon. Okay, but when you get to the point that you have broken down your application into manageable pieces, then you have a series of loosely coupled services. I think that's the idea. And these are messaging, like I said, message-oriented. So the messaging in between these various components is what a microservice-based application is. But they're not application layers, ideally. They don't break them down vertically. You break them down horizontally. Similar in style to Unix, where there isn't one tool to do it all, but say, for example, you want to search for something, then you want to manipulate it, and then you want to take the first word out of it. There is no one command in Unix to do so. You pipe it through, grep, z, les, what have you. And that's the end result is what you want to get. And there is the idea. So you can combine multiple microservices together to get the end result you want. And this is where the clicker stopped working. Okay, what's the benefit then of such an approach? So first of all, you can have independent teams now building their own services. You can, by decoupling them, you can scale them independently. So if one component has a demand for more resources, you can scale it up. So no need to scale everything up. You just scale the piece up that you need. So that gives you flexibility. It also gives you flexibility in the choice of programming language. And ultimately, that should lead to faster deployment cycles. So this is how very few people do this. If you go and watch presentations on YouTube about cloud-native companies, there it works. They say, well, we've got a team. They take responsibility of their stack. They get in there. They own the stack from start to finish. That's where this really works quite well. And also, I'll talk about the choice of programming language there as well. It might be that for some software development things, one language or one tool set is more popular than the other, and it's easier to find people with that skill set on the market rather than getting someone into the company and having him to get up to speed on something that's not quite as common. Okay. But that almost sounds too good to be true, so I was looking at where this doesn't necessarily help. And as with every technology, I think it's important to understand where it can help your case. Just because it helps, the cloud-native companies that have never developed outside of the cloud, if you've got a big established base on-premises systems, then you need to see where this helps you. So often a change of culture is needed when you want to implement this. And a good friend of mine has once said, most problems in IT aren't technological problems, they're people problems. So there's sort of the ratio, 70-30, where getting the people on board to help you move forward into the direction is actually a hard thing. And DevOps is often cited here. So, but not every company is ready for DevOps, I think. And it's also quite disruptive, right? So if you've previously, been shipping tarballs between ops and developers, now all of a sudden, I've got this container image, it runs on this registry, but take that version and don't deploy this one. And then you have to, I think you get where I'm going. Which is why it's so important to actually monitor what's going on. And there's no central, view necessarily unless you design for such an approach from the start. I'm glad Frank is here. So one of the other things when you think about invoking a backend using a REST API, so essentially what you do is you fire off a HTTP GET request or HTTPS, depending on how you secured it, against an endpoint. The endpoint returns data in JSON format. Then it's your responsibility to traverse this and put it into the front end to your liking. Now, and I was thinking, over the last 20 years or so, storage has become so much faster. So we're now down to microsecond response times from storage, and all we do is then wrap that up into an HTTP packet and send it over the wire with higher latencies, shall we say. So if you've got high performance databases, then I'd be very carefully monitoring whether packaging everything into JSON and firing it over HTTP is actually the right approach. Can be quite daunting if you do this. And this is where the Oracle tooling comes in quite handy. So the Oracle Restful data services, which I'm using here, they can help you a lot because they do a lot more than just get, post, delete, and so on. So that's pretty good. So if you want to know more about this, go and see Frank's talk tomorrow. Okay, so how does Docker now fit into that picture? So like I said, previously it's been really hard to deploy code because of dependencies. And I've experienced this firsthand. So on my laptop, I'm running Python, which is Apple supplied, and they have got a certain version of Python on their system. Now I'm using a lot of Ansible to automate things, and I would also like to automate cloud deployment. So I've got a dependency that I would need, but I can't install this because there is a system library which I can't replace. And I'm not going to ruin my Python installation on macOS just because I have a dependency on one particular library. And that's just one example where developers have one technology stack where they say this version of Python, this version of that library, and so on. The same for Node.js-based applications, actually. So you've got a set of systems against which you develop, and transferring that state on your development machine into the system where it's ultimately being run is difficult. And if you've been working in deploying things that you know that there is the state of which a system should be in, and there is the actual state it is in. And despite all best efforts, this sort of configuration drift problem is really hard to get under control. So this is where the Docker thing comes in. So they're not necessarily synonymous with microservices, just Dockers, in my opinion, they really, or packaging applications into Docker containers really enable this in the first place. But the biggest advantage I can see with Docker right now is as it addresses one of the biggest problems with software development, and that is how can I deploy my code so that it works consistently in every environment I deploy it into. And that really is a hard thing to achieve otherwise. If you take just, for example, you've got a VM, and the VM has got a certain set of RPMs installed if you're Fedora-based or Red Hat-based, and then somebody comes in and says, yum update, and the status the system was in doesn't really reflect what it should be in. So then you've got different versions, you deploy, stuff doesn't work because there is a deprecated API or some calls are no longer allowed, and there is a problem. Again, with the container paradigm, in my opinion, this works for lots of people, not necessarily for everyone. And it goes a little bit like this if you look at the success stories. So first of all, microservices, you start to decompose your monolithic applications into more manageable pieces. And I also said that, depending on the team structure and the preferences, it might be that teams choose to implement their stuff rather in one language into multiple, depending on what's just used currently, looks good, and where you get the people to work with it. So that's what I say. One language in the project used, there can be lots of project languages in there. And this is most often referred to as polyglot development. This isn't necessarily limited to the language. It can be the entire stack. So some people might use this database, some people might use that database. And each team can potentially work on and own its own stack. So that means in deployment becomes even more complex, because now no longer are you talking about a single software stack, you're talking about multiples. And I think personally is no longer possible to deploy the application as such on a single entity because of all the dependencies. It could be, even if you manage to get this right for one application, it could be that some other component still uses an older version of the same API and you can't deploy the same things together. And that is not fun. And they challenge the traditional forms of deployment. And wouldn't it be super useful if you could have something where the runtime plus your code are both deployed together? And I think that's what Docker does for us. It also avoids the problem of, but it worked on my laptop. How many times have I troubleshooted something? So I know that works. I've tested it. It works on my laptop. And then you try it in production and it's not quite working. Or it's not the output that you had in mind. So, problem. So the idea is then you take the runtime and the application, you put it all together and deploy this in one entity. So you've got a meta file which describes what the environment should look like. Then you add your code and you deploy the runtime plus the application in one operation. So usually what that means as a developer, or when I did this work and say, I need something that works on Node.js. So you go to the official Docker repository, you check what kind of images, basic images are available, and you derive your container image from the official image. You copy your stuff, you copy your dependencies, and you build it. And after you've built it, you've got something you can deploy. And the good thing about that is I don't have to worry about, recent changes in the dependent packages that I need, because the packages and the version as I need them are already deployed in my container. So that's awesome. And it also makes it very portable. So it doesn't matter where you run it, if you run it in-house on premises or if you run it in the cloud, as long as the image is the same and the runtime information hasn't changed, it should run pretty much everywhere. So that's really good. So if you use this then properly, it should achieve the run everywhere principle. And testing also becomes much more meaningful now, because you don't have this configuration drift between the machines where you deployed to, and because everything is guaranteed to be identical. You deploy, you can run your unit tests against what you have deployed, and you can run your integration tests against what you have deployed. And if you then go from dev to staging to production, or however your chain is, it'll always be the same. So that makes it a lot easier. And like I said, if you really want to take this to the next level, and this is probably the end game, is you take continuous integration and continuous deployment into considerations. And so it's not that hard. I have been able to get GitLab to integrate directly into a Kubernetes cluster. So I can say git commit, and I've got a pipeline in my project, and the pipeline runs, it compiles it, it builds it, it tests it, and if it's all green in all the stages of my pipeline, I can then, there is then a button, and I can say deploy to my cluster, my dev cluster. So I click this button and it goes off and deploys automatically. And this is a great keynote by Kelsey Hightower, who is really an authority on this subject. He has examples where they do this from git commit to deployment completely automatically in a cloud environment, and it's pretty cool to see, because what you don't want to do is you don't want to give your developer access to your underlying infrastructure, because you don't want them to run low-level commands. And they don't care. What you would like as a developer is, if I test something, I would like to see how it looks like. I don't want to, type low-level commands to make that appear. What I want is I commit, and at the end of it, I get to see what it looks like. Okay, so now the application. Now at this stage on this journey where I want to take you on, we're now at the place where we've got a runtime image, which is always the same. I can deploy anywhere I want. Now, but how do I do this? Now, if you think about how Docker does this normally, so if you install Docker on your laptop, on your machines, and you have a Docker build command, it's built a container image, and then you can say Docker run. And you run your application and say it's maybe something that's based on Tomcat, and it listens on a port and it performs the work. You need to map ports of your machine into the container. No, it's the other way around. And then you can, use your web browser, point it to the port, usually 8080 or 8443, and you can see your application. Okay, so now you've deployed one thing to one host. What happens if that host dies? What happens if that host runs out of resources? Or, what happens in any unforeseen circumstances? The worst thing would be you've got 42 Docker containers running on a VM. That VM dies. You've got an immediate outage on 42 places. So wouldn't it be great if we could, kind of exit the boundary of the machine and go to more machines? Or wouldn't it be great if there was something that would monitor the health of my containers and say, if this gets overloaded, the machine it runs on is overloaded, so why don't I start it elsewhere? So this is more or less what the orchestration engine does. And its job, so to say, is to check amongst lots of other things that are far too numerous to mention here. Node failure, container failure, it needs to schedule new containers, it needs to take down other containers, it needs to do name resolution, because that's also something you need to think about it. And you need to expose the containers to the outside world. So this is probably the point where Kubernetes is entering the big picture here. And when I looked at container orchestration some time ago, I mean, I've been looking at that with one eye, but never really paid too much attention to it. There were lots of applications out there that did similar things. So up here, a few years back, notable contenders, as I like to call them, they included Mesos. Docker Swarm is a thing. I put something out on Twitter and say, hey, this Docker Swarm is really easy to set up. And then somebody else said, yeah, but have you looked at Kubernetes? Okay, so that gave me the direction. Docker Swarm is still around, and there is a lot of enhancements in Docker Enterprise that have recently been announced, which I'm not going to talk about in this page. But there has also been Kubernetes, and probably lots of others I don't know about. And it seems that after a few years and the dust settled, we're now consolidating on Kubernetes. Seems like everyone has got some sort of Kubernetes offering out there. There are many turnkey cloud solutions, and it's a bit like with Hadoop. When Hadoop came out, there were people who spent ages of times trying to install Hadoop on a gazillion machines, only to find out that cloud vendors nowadays, you can just go into the cloud GUI, I want this version, I want that many nodes, and just go and do it. And you get a coffee and you come back and it's there. So the skill of building these things is probably not necessary, because you can get all of this in the cloud, and you don't have to learn the basics as much. You can rely on the cloud vendor to do that for you. And Kubernetes, if you look at that from a community perspective, there are lots of people who say this is the basis for stuff that you build on top of. And the most prominent example I know is Openshift. Openshift is a Red Hat project initially where they had developed their own, but in version 3 they switched to Kubernetes as the container orchestration engine. So how does it look like? And that doesn't really need to scare you. I hope you can actually see this. So there's essentially, there should be a gray box around this master. There are components like the API server, the controller manager, and a scheduler. And then you've got this thing here called etcd, which is a key value store. This is where the state is kept. Then you've got nodes, and there are various components here. A container runtime, there is a kubelet that talks to the API server and vice versa. You've got DNS, and you've got a proxy. And then you've got these things called prods I'm going to talk about in a minute. And you can have lots and lots of nodes. That scales out pretty well. This etcd key value store is something that's very often combined on the masters. And there are usually 3 masters across 3 availability domains or zones, or whatever the cloud vendor calls his data centers in a region for high availability. But the cool thing about that is that you don't really need to know about what's referred to as the control plane, because that's being handled by your cloud provider. What you deal with is this, and even then you don't necessarily deal with these components, you just deal with the interface and how to create your application in this cluster node. And on the very bottom you've got a network, a flat hierarchy of IP addresses across all ports. That's how it works. And so when in Docker you've been working with containers, in Kubernetes you work with pods. Most of the time you've got a one-to-one relationship between pod and container. That means there is one container that runs in a pod, except for if you say you've got a sidecar proxy that you run in your pod for managing your service mesh. That's something that we saw in the Istio talk before mine. So that's the case when you've got multiple containers in a pod. And if you've got multiple containers in a single pod, they share resources, and this is why this Istio thing works so well. Unlike in Docker, where you, in plain Docker, not Swarm, you usually create, in Docker you create containers, but in Kubernetes, although you can create pods as a single entity, that's not what you usually do, because they are implicitly created by other entities that are higher up in the service level hierarchy. So pods come and go. They can be considered cattle in the kettle and pad analogy, and they're those ones that are controlled by the scheduler. If the scheduler detects one that's gone, it creates another one. If you want to scale up, you want to have more copies of the same thing, you get that too. And the kind of transient things, really. They don't self-heal by themselves, and they're usually created by some abstraction layer. They also get some really random names, and I'm going to talk about how these get assigned later when we talk about the controllers that create the pods. So there is the most important one probably is the deployment, and the deployment uses a replica set. I'll talk about that in a bit. And then we've got a stateful set as well. So the pod names are random, except for those that are created by the stateful set. Now let's have a look at these. So if I've got an application here, I interface into Kubernetes using a tool called kubectl or kubectl, and I can then say get pods, and I show the labels. So I assign labels to my application. So this is my front end, and this is my RESTful data services implementation. So I can say, or give me all the pods with a given label. And you can see this is the name of the application, front end, but then you can see there is an almost arbitrarily, seemingly, number of characters behind there. And you can see they're all healthy, so I've got one and I want one. Okay, pods on their own aren't particularly useful because you scale them up and down, and they may die and they get recreated. So that's the job of the replica set. So the replica set is kind of looks at all the pods on your and it checks whether they're healthy and whether they run. And it identifies these pods by means of a selector, and the selector I just showed you, because you annotate your pods with labels. So, but then again, you don't really create replica sets yourselves either. But you can query them. So there is a command here, describe replica set rs. And this is the replica set for my front-end application. You can see there are my selectors and labels. And it says I have 5 current, I want 5. And these are messages that it said. There should be 5 messages. 1, 2, 3, 4, 5. There are 5 messages. One is cut off. Well, it created those successfully. Okay, but when you don't create these, how do you create the pods after all? And this took me, when I first looked into Kubernetes, it took me a little while to find out. So you don't create these things by creating pods themselves. You don't create replica sets yourselves usually. What you do is you create a deployment. So the deployment really is the thing that describes your application. It says, deployment for my front end, it should use this container image, how many copies of my container image. I can then specify some other properties, and the scheduler then takes this description of what should be done and makes it happen. And this is the job of the kubelet on the worker nodes. The worker nodes actually were called minions at one point. That's a great name. I like that much more than worker nodes. Okay, so the deployment is also something which you can modify. So say, for example, I've written version 1 of my front end, and now there is a sprint, an iteration of my software development, and I would like to have a version 2 of my front end because the button is now, let's say, green instead of blue. Green is all better, so I want to replace this. And I can do that in terms of a rolling upgrade, which is really cool. So when you then say, I change my image, container image from front-end version 1 to front-end version 2, you make that change, and Kubernetes will do this in a rolling fashion. So that the idea is that you don't take all the pods down of version 1 and then you start all the pods for version 2. That would mean outage, where we don't really like outages. So it's done in a way where it takes a few down, starts a few more, takes a few more down, starts a few more up, and so on. So this is totally rolling. And there shouldn't really be any impact to service availability, which is also very cool. And the best thing is that if you find out, oh, damn it, how could we possibly miss this bug? And you need to go back. You just can undo the rollout of your deployment. So it'll go back to front-end version 1, and after a short time, nobody will even know. And if you've done it really cleverly, for example, by weighted services routing, when you've got a service mesh, you can define rules. You can say, everyone connects to version 1, I roll out version 2, and then you say, well, maybe X% of traffic, let's say 5%, 10% of the traffic I route to my version 2 of my deployment. So you can then fire up all your monitoring infrastructure, and you can see, oh, that works. Oh, there is an HTTP 500, like an internal server error. Something has gone wrong. You can investigate. And if this is a one-off, then it's okay. You can continue with the rollout. But if you find out that new Canary deployment, as it's called, if that didn't work, you can roll back. And you have very, very little service impact. So it's pretty cool, and it's all in containers. There is then the topic of so-called config maps and secrets. So if you want to parameterize your containers, you want to pass in variables to the containers when they run, you can do this using config maps. This is just one way to configure your system. It's way cleaner, I personally think, than using environment variables in Docker. Because they're sometimes not ideal. So who would want to pass? So for example, if you run MySQL, or when I last ran MySQL, you need to supply the root password as an environment variable. No, well, not so sure if that's so secure. There are, of course, workarounds to that problem, but you wouldn't want to pass confidential information in clear text. So in Kubernetes, it's slightly different. You've got config maps for, say, to say things that are publicly visible, that shouldn't be particularly hidden from view, but you also can have secrets, and a secret stores more sensitive information. And I thought that's really cool, because finally I can pass my sensitive information into my container and I don't have to worry. And then I looked into the secrets a bit more, and then it turns out their values are base 64 encoded. Even I can decode base 64, that's not too hard. So maybe they're not so secret. Or maybe I haven't looked into that enough, I don't know. Okay, so now you've got containers running. So wonderful, but you can't get to them. How do you get to the containers? And this is where we now get back full circle to the microservices. You need to expose the container, or the deployment rather, by means of a service. And there are various ways on how you can do this. The cluster IP, this is for internal services. So say, for example, you've got, let's say, a Java application, like a servlet. The servlet connects to it, to something else, and it pulls information from that servlet. You can use a cluster IP because this is cluster internal only, and it's never visible outside. One way to get access to your application would be by means of a node port. So that maps a port of the cluster, of the container, into the 30,000 plus port range, and you can use that so to access the application, and you will see that's what I do later on in my demo. Load balancer is something else. If you expose an application by means of load balancer, which is primarily possible only with cloud providers, is the cloud provider will spin up a load balancer for you, and say you've got 5 instances of your front end, it will connect your 5 instances of the front end to one instance, which can be protected by means of SSL and so on. And you got round robin or whatever distribution method you would like. So you hit that endpoint and it moves to the first, then to the third, then to the fifth, then to the second, to the third, and so on. So there is kind of a load balancer, but that's something that requires extra resources, and I've only seen this with cloud providers. External name is something I'm going to use with my application, where I'm just making a DNS name which is external to the cluster available within the cluster. So I can say my service Oracle XE is known inside the cluster, but it points to some database that I've got elsewhere. So the way these work is also based on selectors, and they live on level 4 of the internet or the OC model. There is also a DNS component in Kubernetes that makes name resolution possible. Okay, now there is this discussion about persistent storage in not only in Kubernetes but also in Docker. And from what I understand is that containers should be transient in nature, ideally stateless. So should you really maintain state in a container? I personally wouldn't want to, but there are other people who really would like to. Opinions are divided, really. But if you want to have some sort of persistent storage, you need persistent storage, because when you kill your container, what's in your container is gone. So you need to have a way of making that available outside the container. So if you want to do this, you think of volumes, and in Kubernetes these things are called persistent volumes. So you can then say, in my Kubernetes cluster, I make a 50 gigabyte volume available for anyone who wants it. And the who wants it part is the persistent volume claim. So my container that I'm spinning up, I can say I want 5 gig of a persistent volume. And the good thing is that you can also have claims that don't require a pre-created volume. That can happen automatically on the fly. And with that, you can then sort of mount something into your container or your pod, so to say, and this is where it runs. And then we've got the stateful set, which is a new controller, and it allows you potentially to run stateful applications in Kubernetes. And it takes away the randomness from names, so it will enumerate. It will be pod -0, -1, and so on. So the naming conventions are more predictable. And what I have seen on the Kubernetes website is that they do this for MongoDB replicas, for example. Okay, so having said all that, time to tempt the demo gods. Okay, so why can't you see this? Do I need to? Okay, now you can see it. It makes much more sense if you can actually see what I'm trying to show you. Okay, so this is my feeble attempt at writing something in JavaScript. I suck at front-end development. But it's really nice. So if I say, for example, I put in my login form, I can have validation rules in there, and I can authenticate myself. So I'm then logging into a database, into my application, and that just shows you the components that I've used. So it's Vue, Oracle Restful Data Services, and Oracle Database Express Edition. So out of this, the Database Express Edition runs in a VM elsewhere, so it's not part of the Kubernetes cluster. Restful Data Services, they run within my Kubernetes cluster, and Vue runs in my browser. So the tricky bit will be when I go to the home button, and this is where it's supposed to fetch data. Now, I've hard-coded the endpoint to a different system. Oh, hang on. First of all, this is what it looks like. And so this is me calling the REST API provided by Oracle Restful Data Services, and it's listing all the employees in the employees table. So the thing that I need to do is I need to go in here and paste that and confirm. And it now in the background, it should go and load the data. And it loaded the data, and it did so asynchronously. So it uses Ajax in the background, and this is the result returned from ords. So I can now make use of the pre-configured components. I can scroll through there. I can say this is 25 rows on my display table. So this is essentially how you could do this. You've got a RESTful API sitting in the back end, and that talks to the Oracle database, and you've got whatever front end. I mean, it doesn't have to be JavaScript. Anything that is able to ask for JSON and get it back, so essentially get a HTTP GET request, and then parse it and show it to the user. Anything is possible. So if I said, oh, I don't really like to write this in Java anymore, maybe JavaScript, sorry, I want to write this in whatever is currently hot, and popular, I could just rip that out, replace this service with something else. I change the deployment in my Kubernetes cluster from this version to the current version that I've developed and tested, and it's all found to be good. And there we are. So I don't need to worry about the backend anymore, because the backend is provided, through other means. I can now independently focus my team's efforts on those things that I want to change. And I think we're pretty much done for time. So does anyone have any questions?
Yeah, I have a question.
Hang on, there is somebody with a microphone coming.
Yeah, you told that, for example, we have version 1 and then we have version 2, and so we have more components which we should load. And so you told that we should not load all the version 2, but by parts. So how could you achieve this? I don't understand.
Okay, so what you're talking about is the Canary deployment. And the Canary deployment, sort of, going back to the times where people were mining, they would take a canary, a bird, in a lantern down with them. And if there wasn't enough oxygen, the canary would die. And so the miners know, it's pretty harsh. So the miners would know, we need to get the hell out of here. So the same idea applies to these deployments. You take your Canary, which is the new version of the software. You define routing rules. So if I, for example, I connect to this URL, so I deploy, I say everyone connecting to this application through a load balancer probably will end up here. So everyone sees this. So I can say that everyone comes in should only end up there. So I now deploy my new version of my code, and then I can say, 95% of all requests should go there, so as to have very little disruption, and 5% of my incoming requests, customers, users, whatever, they go to the new version of my software. So this is how this can be done, for instance. If that doesn't answer your question, then let me know. I'll be around still afterwards. Any further questions? It wouldn't appear so. So thank you very much for bearing with me, and I'll see you around.